So we have seen RAG, retrieval augmented generation. Now there are some other problems and techniques to improve the output of generative AI solutions. That's what we are going to look in this particular lesson based on the study guide. Again, another set of techniques to improve generative AI model output. So far we've been discussing prompt strategies, RAG and things like that. Understanding about the foundational model limitations. This is one of the key things. We need to understand the limits. Like I mentioned, the size of the context, that is one of the major limit. We need to play everything within that context, input, output, system prompt, our prompt, everything includes in that particular context window. Data dependency. Foundational model performs heavily based on the data which is available to it. Incomplete information, incomplete prompt will affect the output. We have seen that. That's why we have additional context giving mechanism like tooling, prompt strategies, RAG, etc. Knowledge cutoff. The base model is always trained on data which is available to certain days, like 6 months before. But we can overcome this particular limitation using tools. For example, if you ask Gemini what is the date today, it'll give you the correct date. There's a chance that it'll give you the correct date. Using tool, it'll just call an API to get time, like the way we got the weather information using API. Tool use will overcome this kind of problems. Search tool. It can search in the web, get the data, and query based on that data. Bias. LLM learn from large data sets. Like I mentioned, the Wikipedia corpus. Even subtle biases can be magnified in the output model. So this particular issue has been a big issue for Google a while back. It was generating some kind of racist images when it was generating images based on some kind of historical figures and things like that. They have apologized for it, but I'm sure they have learned their lessons and corrected all those mistakes. I'm pretty sure this particular sentence is coming from that particular mistake. So it can get magnified over training epochs. A training epoch is nothing but one full set of training with the same data. It's very similar to you learn some information, some book again and again so that you will remember it. One learning from the same data or same material is one epoch. Fairness. Assessing the fairness of a generative AI model is a key aspect of responsible development. This is all coming into the vicinity of security. If the model is becoming unfair, unethical, imbalanced, then there's a huge problem. There is a lot of consideration has been put into all these items when they train the model, making sure that it is giving ethically correct answers. Hallucination. We have seen hallucination before. The model produce output which doesn't really matter, or accurate, or inconsistent. Doesn't make any sense. That's when the model is hallucinating. So neural networks are by default designed to hallucinate. They are supposed to produce some data for every single input. That's the general nature of neural networks. Even the hello world neural network will do that. So it is inherent in the lower level of neural networks, which comes in large language model as well, because large language models are nothing but made of neural networks. So we have seen some of the strategies and tactics and tips to avoid or reduce hallucinations. These days, this problem is very less prevalent, but when these all started, hallucination was very common. Edge cases. When we ask certain questions, the model misbehave. Until recently, one of the popular edge case was asking any model number of R's inside the word strawberry. The models used to get all kind of numbers. Another edge case always models used to struggle was how many number of words in your response. It's even a difficult question for humans. And there are some edge cases in which you run into loops and all those kind of things. I don't think it's a real issue unless you really tweak into it. Humans in the loop, or HITL. This is a common practice in all the training paradigm. To moderate content, catching harmful material algorithms, moderating content based on the output the models are giving. Humans will evaluate if the content is good or not. Sensitive application, healthcare, finance, everywhere it is always good to have humans involved. Don't trust the machines only. In fact, I believe this is a very important thing in future, especially when it comes to security. Models will keep on taking more and more workload. People will start trusting model more and more. There is a time when human intervention is reduced and problem can happen. High risk decision making, again another place where humans are supposed to do its thing. We should not trust models with something like a nuclear weapon or any such high risk decisioning. We need to always verify. Humans should always verify. Probably multiple humans should verify what the models are doing. Pre-generation review, human experts review and validate all the outputs produced or catching errors or biases before user impact. Very important. Extensive manual human testing of the output of models. Even after releasing the model, we need to keep an eye what the model is giving. If it is causing any kind of trouble, take it down, fine tune, whatnot, based on the issue we are facing. So managing your model, we have seen the Vertex AI offering of Google Cloud. So versioning, so you have to have a version for your model. You have trained, you have fine-tuned, you have tested, all should be versioned. So we have Vertex AI model registry where we can keep different versions of the model. Performance tracking, how the model is behaving for a particular test case, how is the test case is succeeded, what is the error rate, and things like that. That is the performance tracking. A drift monitoring, watch for changes in the model accuracy over period of time with Vertex AI model monitoring. So Vertex AI provides a lot of tools to test and monitor the models which we are training and creating. Again, in Vertex AI, we can store the data with which we are training the model, or we are creating the model from the base data. And of course, we can use the model garden to store the model once it is created and potentially sell the model to other potential parties. And we have seen the automation, the creation of the model from the data, testing of the model, deployment of the model, and then finally fine-tuning after the user feedback. All this can be automated using Vertex AI ML pipelines. Almost all the cloud providers these days have these pipelines, the ML pipelines, to do exactly what we have discussed. And we are discussing about ML ops in detail in Azure Cloud in my other training. Additional items, context window. We have discussed a lot about context window. This is one of the Achilles heel of large language model in my view, context window. Because this context window, models always behave like an alien which doesn't remember the last conversation you had unless you keep reminding it about it. A very smart alien which doesn't remember the previous thing you talked about. All it can remember is whatever you are giving in this context window, unless it is trained on the data, of course, or fine-tuned on the data. So this is the fine-tuning comes into the picture. So we can fine-tune or train a model based on some data. Remember the 1 GB private data we had in the RAG session? We can use that 1 GB to train the model and create a fine-tuned custom version of the model. That's where all these things comes into the picture using Vertex AI. We can fine-tune using our private data. It is expensive. It is not cheap. It has a lot of effort involved. Not as much as creating the model itself, but definitely we need graphics cards, GPUs, and things like that to train or fine-tune the model with the private data. So fine-tuning is a methodology like RAG, probably if it is fine-tuned properly, better than RAG, but a lot more knowledge and effort and hardware is required for fine-tuning than RAG, another methodology to overcome the context window problem. So we have seen some of the limitations of generative AI models, like hallucinations and things like that, and some mechanisms and best practices to improve it. We'll keep continuing our journey in the next lesson. And thank you for watching. I'll see you in the next.